no. Come on. Do it all, machine. You can handle it all. Come on. Don't screw up my theme music. Oh, wow. Alright. Well, actually, now the background track is part of the experiment. Good grief. Good morning, everybody. This is Alex St. John, aka the Saint, streaming to you live from the Playcast barn out here in sunny Redmond, Washington, in the middle of nowhere. What is it? 6:05 a.m. So I started, how many hours ago? The evening shift, I started around 5 p.m. yesterday. So I've been here. It's getting to be the crack of dawn. I'll be able to sneak in the house and get coffee without waking everybody up. I'm running out of firewood here, so I have to put all the teenagers to work stashing the fireworks. So when the stove runs out of firewood out here, that's when it's time to call it a night. All right, so a couple days ago, I did a massively popular episode about spongling, which is what you do when you're a brilliant engineer who works all night to exhaustion and hallucinates incredible progress when there was none. What's this? My security system went off. Who's here? Let's have a look. Is it Amazon? Who's delivering? We'll check all the spy cams. Oh, my family's getting up there, letting the dog out. Oh, nope, Amazon delivery. There it is. Oh, I'm almost tempted to go and scare the crap out of some poor delivery person. They'll probably think we're all asleep. Ooh, I wonder what I got. Is it Christmas again? Alright. Sorry. I don't know what we need a security system for. We have dogs. Working out here to the crack of dawn, and published a wildly popular video about hitting 500 frames a second capture rate with the Playcast software I'm developing here with my team of Kiwi, Philippine, and Tennessean engineers. So we hit this. I've been working on it for 3 years now. It's version 1.3. We put out just before Christmas, the best one yet. Go try it at playcast.io. Smash the like button and subscribe. But for those of you who haven't seen me before, I'm Alex St. John. I started the DirectX operating system at Microsoft. That's the creator of your DirectX operating system for your DirectX box. And I'm working on a new revolutionary streaming media platform, I hope, that's meant to make it possible to stream games from your own home PC to your friends live in a browser. And browsers suck, so the degree to which we do it very successfully is a miracle of overcoming the limitations of crappy browsers, I have to say. But I'm having a lot of fun out here. So a few days ago, as you can see over here on the middle screen, let me blow this up. I should explain what you're looking at here. If you didn't see, go back and look at the Spongle episode where I show you 500 frames a second, and you will see right up here on this page here, we are clocking 500 and something right now. Let me blow that up a little. Oh, it's not in the front. Okay, let me go to order, bring to top, move to top. You're looking at a system with many, many displays all hooked up to it live. This is a hell of a big media computer, but we're killing the poor machine. So hopefully you can see up here in this upper corner, let me see if I can zoom in there. It says we are averaging 499 frames a second, which is the fastest I've ever been able to capture a desktop window and jam it into a browser. Which is what I'm testing here right now. And so each of these windows, with the exception of one of them, is actually one of the many monitors plugged into my main development supercomputer here, except me, the overlay, and this window up here. I don't know if you can see my mouse. Can you see what I'm pointing at? The upper left-hand corner. So what we have is this screen here on the left side that just looks like a bunch of ants crawling over, like a bunch of cosmic background radiation. That is my test program, and this is a very useful little program I wrote to help me test video capture and streaming efficiency. Because one of the things you're trying to do is separate the performance of your software from the performance and efficiency of the encoding encoder. And so what I did is I made a program that runs at the maximum frame rate possible. Under this particular circumstance, it's running at around 1300 frames a second of random noise. And the reason for doing that is I'm trying to get the most frame rate I can. Now the refresh rate of the monitor that's capturing here in OBS is 165 Hertz. It's rendering at 1300 frames a second, and if I didn't have all this crap running right now, I have lots of stuff running, it usually runs about 6,500 frames a second. So it's meant to test the absolute fastest rendering I can achieve on this computer. And then I expect to be capturing at 165 frames a second. That's where I want to be at. And so the question is, when I see in the browser over here on the test page, and this is the other thing I worked on over Christmas, see the screen above that looks like the static screen, this is not one of my monitors. That is the Playcast virtual camera that I'm rendering my capture from the desktop, so both OBS and Playcast are simultaneously capturing the same displays, capturing all of them at once, which is a crazy thing to be doing on the computer, and is outputting them both. And then OBS is picking up my Playcast camera and sees it as a camera, thinks it's a USB camera, and is rendering it here. And then my code that is tracking the frame rate internally so I can tell the difference between the real frame rate and what the browser is reporting, the browser webcam test page is reporting, so I can see the contradiction. And then up in the upper right-hand corner, way up here, well, I'll maximize this one just to really confuse the crap out of everybody. That upper right-hand screen, that's the Playcast Host Apps preview window, also viewing the same camera. So the Playcast virtual camera, there are 9 of them, one for every player or spectator viewing their own stream from your home computer, your own game stream. One of them is rendering in the browser. The next one is being captured by OBS, and the third one's being captured by the Playcast software. And all of them are being updated. It's a running average of 1 second, so it updates every second to show kind of what the running average capture frame rate. So what's the number I want to see? I want to see the number 165. And before I turned on all the cameras and the microphones and all the capture stuff to do this demo on the same machine, I was getting about 148 frames a second through the browser. So I'm pretty happy with that. That's pretty darn good for I'm capturing 160, and I can explain what the difference is. I like the difference between 148 and 165 because I understand where that number comes from. It comes from copying the frame into the virtual camera on the same thread that is doing the rendering and compositing of the frame. And because it takes a little time to copy that frame through memory, that's the difference between 148 frames a second and 165. But when I turn on the Playcast app, Open Broadcast Studio, and the browser, and my static generation app is always live, that's all burdening the GPU. It's all camping on it and copying that video frame, and they're all picking up that video frame and rendering it. And so the frame rate that was about 148 frames a second before I turned everything on here is now clocking about 70 to 82 frames a second. So all that is good and is expected. The mystery is why the browser is reporting 500 frames a second. And when I test it with regular cameras, regular USB cameras, because I have tons of them, that comes up with a great result. When I run the current released Playcast software 1.3, that we released just before Christmas, it shows the right result. But my new software that I just re-architected over Christmas to go incredibly fast, it's reporting 500. Now, And this is not my code running in the browser that's reporting it. That's a generic test page I like to use that's somebody's hosting out there. So why does it think I've got a USB camera outputting 500 frames a second when I believe I'm only outputting about 80 frames a second under this condition? And I should be outputting about 148. And the 148 is just the difference because this is single threaded for testing. So the time it takes to copy before I go around the capture render loop again, that little gap for the memory copy is the difference between hitting 148 frames a second and 165, which is where I want to be at. And I can be at 165, that I know how to solve because I've simplified the code so I can do all this surgery to it. You know, you do surgery in a surgical room, not, you know, in your garage. Wait, maybe that was the wrong way to explain it. I do surgery in my garage, actually. But so the thing that's perplexed, oh, now it's actually hit an average of 500 frames a second. So what's going on? Well, my virtual camera, which I perform surgery on to jam these frames down directly, it thinks somehow that it's getting 500 frames a second. And I believe what is happening is that it is resending the last frame that was genuinely sent as fast as it can, and that's maxing out at 500 frames a second. So on the one hand, if I could capture and render 500 frames a second, and my render loop is rendering, well, we'll have to do, you can do a test on the render loop, but the render loop can render video frames that fast. Capturing them is limited to the refresh rate of the display. But the fact that I'm actually able to jam through duplicate frames at that rate makes me happy. That's good to know. But why does the browser think I'm sending 500 when I'm pretty sure I'm only sending 81? So again, I'm doing surgery. I had to pull apart some very complex code in order to do this. And what I think is going on is that the threading code for sending frames out that is in the released product, the previous version of this code, may still be running in the background and may be sending null frame messages to the virtual cam, triggering it to keep sending that whatever last frame it got over and over again. And that's why and notice it's hitting that number. Yeah. Let me show you something that's suspicious here. The number it's hitting is 500. So I'm going to go over to my camera IO code. You probably can't see what I'm doing here, but I'll zoom up on it. But I'm just going to a part of my code, my virtual. This is the object, the C++ code that feeds the virtual camera. And I've got some test code here. And let me see if you can, let's zoom up. Maybe I can just do it by zooming like this. Let's see if that makes sense here. All right. I don't know how many of you are C++ programmers, but if you're a web developer who, you know, likes toy programming languages, this part here won't look too alien to you. Let me see if I can blow this up a little bit. Order. I'm messing around with local broadcast. Move to order. Move to top. And then let's zoom up. Okay, you see this code right here where it says camera properties.fps equal 500. Well, this is my test code that is telling the capture software to capture at 500 frames a second. And I picked that number when I wrote this code because it should be faster than anything that's possible. And by sheer magical, impossible coincidence, we're getting the exact same frame rate reported by the browser. So that's our first clue as to the nature of the bug. So we can run a little experiment here. Now, when I do this, I'm going to lose the Playcast application. Will need to be restarted to pick up the thread because that's the actual, I'm working on the actual shipping product, so it doesn't have all the developer code in it because everybody's away on vacation, so I didn't want to bother people over the holidays for development builds. I know how to make them. This is just, it works, it's quick. But what we're going to do here is kill this thread, terminate all. So you should see That's the page, the Playcast placeholder frame went there. It's up in that upper corner where it's actually where Open Broadcast Studio is capturing a virtual camera. Let's set this thing to pick a number. Let's set it to 217, a really weird frame count. And then we'll build the program, build it. And let's just say, and I didn't practice this. It's 5 a.m. I'm tired. It's getting cold out here because I've run out of wood. I can't go crashing around bringing wheelbarrows of logs in the house with a house full of sleeping people. So, so when the heat runs out, it's bedtime for a couple hours, and not when the kids get up. So it's going to be a while before I get a nap in. All right, here we go. So it builds debug, start without debugging. I'm not trying to run debugging code because the debugger slows everything down as well. I want to run at raw frame rate. There goes the camera. Now let it heat up a little bit. Then I'll hit the FPS frame checker, refresh the page, just to start everything up again. Here's my whole list of Playcast shadow cameras. These are all virtual cameras like OBS. I'm going to pick the one I'm working on, Shadow Cam 0. And let's see where it goes. All right, and so now again, the other thing that's important here is that in order to test everything, you want the my test program that's generating static at the fastest frame rate possible, because I want to make sure that I'm actually confident that I'm capturing at the rate that the display is refreshing at. So the way the low-level APIs work, I'll only capture a frame if something is changed on the display. So I'm making sure something is changed on the display as fast as it can handle, running about 2,000 frames a second there in the test program. So that ensures that anything less than 165 that I'm not capturing is my fault, because I should be able to get it. Now, this is interesting. The average is not hitting 500 frames a second now, is it? Notice that the other frame rate, the average frame rate picked up because the Playcast app's done, so it's not competing for all the video streams that are coming through the camera. So it's a little faster there. But look at our average frame rate there. It's not 500 now, is it? No, it's not. It's kind of closer to 217. So I believe there is a bug in my prototype code in here somewhere that is tickling the camera to believe that new frames are arriving when they have not, and then it's resending a previously sent frame at or near the requested frame rate, and that's the bug. So again, the goal, correct behavior for the system, is to nail 165. I think I know how to do it. But I go, okay, I'm a little bummed that, well, I've never seen it actually drive 500 frames a second and have the browser go, yes, you're handing me 500 frames. That's the first time saying, I kind of want to know how high I can go. And the requirement is I got to send the same frame. And then the next interesting test, which we'll do when Aiden's back tomorrow when I get his test framework set up, is run it through the encoder and decoder on this machine. So you get all the latency of the hardware encoder and decoder steps, and get to see what the real limit on the frame rate actually is once you're simulating having sent it to somebody out over the web. Yeah, I bet you if I sit here and yak long enough, that 199 may stabilize closer to 217 than to 500 frames a second. So I suspect I know where this bug is. And so we have a mixed win. The new architecture is capable of 500 frames a second. If I could capture 500 frames a second from somewhere, you know, a high enough refresh single display or all these displays combined, for example, then I could probably deliver it to that many virtual cameras. Pretty cool. So that is a big advance, big progress. But the correct speed is to be delivering frames to the encoder at the refresh rate of the display, which is 165 in this case. And I think I know where to look for this bug. I think I'm sending a false frame ready signal down to the driver from the code that is written to handle it in the previous architecture. And if I stop that from going on, then I think I'll start nailing my frame rates. And again, what I expect to see is about 148, which is what I get when I don't have all this stuff running. All right, wish me luck. So that's the progress update. So not a total spangle, but not absolute Christmas yet either, because as you can see, I'm getting heavy contention for my frame rates from all the apps running. The Playcast software doing the capturing and streaming is getting weighed down heavily. But again, not actually a problem under regular use, because that video isn't getting played on the machine that's capturing it. It's getting played by people viewing it over the network with another device. So the fact that all this capturing and playing the stream at the same time is slowing me down on my development machine is not really a big deal. But as a brilliant engineer, I do take pride in not letting the physical limits of my computer get in the way of a great idea. So if I can think of a way to outthink the machine, I will. The update is that the new Playcast app, I think this is definitely going to be an improvement, but I still got to move some stuff around. And we're using my new text overlays. So one of the problems is getting frame rates, tracking frame rates through all the layers of architecture and browser and over network back is quite complicated, because we're passing through lots of layers of stuff. So this text overlay feature I just wrote lets us essentially timestamp every frame of video directly as it's captured, and so when all the various clocks tracking things going through come through, you can actually check the video's own local reference timestamp in text in the video frame alongside the number you're generating to see if we're clocking it right. So this is a test for the engineers. You go, yeah, this is impractical. I don't want to have to write text recognition software to get the time from these frames. But if all of our engineers are trying to get low latency benchmarks, performance profiles through this convoluted architecture, how do you know you got it right? How do you know it's calculating right? Well, every frame will come stamped knowing its own time, so you can just visually check the time it says it was captured and the time you recorded the latency, see if the numbers line up. So that's a way of being sure that your huge team-built metrics for tracking latency performance is actually correctly tracking the latency. So what is it now? 6:27 a.m. I'll have to check all my security cams to see if dogs are getting let out. As soon as I see the dog, as soon as the alarms go off with the dogs going out, then I know that the wife is up and I won't get in trouble coming in for coffee. But I have not had the dog trigger yet, so we'll see. But pretty soon, and I might have a couple logs left to stay warm out here in January in Washington in the winter. So I'm Alex St. John, aka The Saint, having a good time out here in the Playcast barn in the last waning day of the Playcast Christmas break before everybody comes back to work and we start a new sprint. So I really want to have this work wrapped up before everybody shows up and starts distracting me with management responsibilities. So good progress here. For those of you, I just did a big stream on Agile. I'm deciding whether I like it or not. But one of the things I talk about is basically this capability, assuming that I finish all the tickets and it's tested this sprint, would then get handed to the web guys who would put the capability and automate it in the UI. And so you might start seeing this architecture come through in the late January. I think it'll be the 1.4 or 1.5 release of the Playcast app. And so you can see it getting developed here. So anyway, I'm Alex St. John, aka The Saint. You all have a good morning. And I just did a long soliloquy in response to one of my many subscribers' questions about when I'm done optimizing. And by the way, why don't we do it for a second? The short answer to that question in this case is, first you make your software work, then you make it work right, and then you make it work great. So the order of operations are: you make the software work to show your investors and potential customers the cool idea and terms that they can play with it, interact with the concept, and see if they get excited about it. Then you build it to work right, which means you make it stable, you productize it, you make a minimum viable product, and you ship it to the market. You get one in beta and in a 1.0 release, and you ask people to use it and give you feedback. Then you make it great based on that contact with the market and feedback of people actually trying to use your tech. You get hard feedback, and you go in there and you make it, do whatever you have to make it the thing everybody wants, rather than the idea you had that you hope they'd want, because that's what you have when you first usually get a product to market. So in this particular case, because I know these video and media architectures from end to end, I know the shortcuts I took to get it done, to make it work, make it exist. Existence is the most important feature of a new product. So I knew what trade-offs I was making when I made it exist. And one of the trade-offs is I used a lot of open source code to put the early prototypes together. And I did a lot of memory copying, which added latency but got it done quicker. That was a long time ago, years ago. And now I'm surgically removing every memory copy. So this particular architecture is the 1.3 has one memory copy through the system to get to the browser. This has 0. So it goes straight to the Chrome memory address space in one copy. That's the big thing change I made. And then the only thing I can do beyond this to go a little faster, maybe a lot faster, and that's why we have to do the metrics next to see how much is left. But I would estimate that there's at least 1 to 3 frames left for me to get. And I would get those by not using the browser's WebRTC to do the streaming on the other side. Cloud gaming services like Stadia or Microsoft xCloud or Amazon Luna, they're running these services on Windows or Linux boxes or Windows VMs in their cloud architecture. And they're running NVIDIA drivers which do this capture for them, and then they're passing it straight out through their own C++ WebRTC implementations. So they're not using a browser which was not designed to do this for gaming to do their capture and streaming. We're getting a lot out of using that architecture. We're getting to market fast. We're getting a lot of features set. We're getting beautiful browser integration. Because we've done all this work, but there is a little latency hidden in there that is going to be the last bit to remove. That's hard to get out of there. But there's a lot of work to do to get the latency and other things perfect under all conditions. So the product and the platform we have is very good. It's never been done before. But the goal is to make it great. So we're entering the phase where we're still here at Playcast. We're making it good. We're putting it in people's hands and say, try it. Tell us if you're like how you can stream games with your friends. Tell us what works. Tell us what doesn't. Get to our Discord site and give me feedback. And so probably the schedule is next year is focusing on going from good to great. And good to great happens when you put it in the market. You ask for feedback, you ask people to use it, and then you listen to what they say, and you change your mind about what your notions were and your assumptions were in response to market demands, and generally the market will always reward you for listening to it. So that's the phase we're in now, which is one of the reasons I'm up talking about it today. Is if you're interested and you want to help out, please, I'm up on our Discord channel if you want to talk to me directly periodically. Give it a try. Playcast.io, go get the Discord link, try my software, give me feedback, tell me what you'd like it to do, or ask questions. As you can see, I'm always happy to try to answer them, however long-winded I may be. So anyway, that's the shorter version. Now I'm going to throw a remaining log in the fire until the security system tells me that the family is awake, and then I will see you all on the other side. Have a great morning, and what is it, Sunday? Yeah, Sunday. So, I'll probably go have some coffee, hang out with the kids for a bit, have a nap, and then start the day shift to try to get this out to release. And I can see my engineers are waking up. I see commits kicking in again. So I think some of them were coding over the holidays like me, but didn't want to signal that they were being productive, secretly productive by committing. So I see that the new AudioCast driver looks like it's coming in. So I can't wait to see what that is. A brilliant engineer, a better engineer than me, which is really hard for me to admit, joined us recently, and I handed him the task of writing the new AudioCast drivers, because I work so much on the video side, my strong point, that I neglect some of the audio capabilities, so he's picked that up. So I saw him committing that code, so I'm excited to take a look at that and see what that's doing. Anyway, you guys all have a great morning, and I'll see you on the flip side. We'll be back at work on Monday. Some of you are probably back at work already, but give the software a try. And I'd say I'm 50-50. This is interesting. I bet I know where the bug is. I'm going to go hunt it down. I'll report what I find. So I set 217. I deliberately picked a prime number frame rate because it should be impossible to hit without an oscillation, so it's going to stabilize it here around 200. I'm pretty sure I'm correct. Other weird thing is, as I've been talking, notice that it's been speeding up. Who ordered that? Good grief, computers. But I'm doing a lot. There's crazy stuff going on. Lots of software running all at once, all fighting for the media capabilities, so who knows. Y'all have a good day, and I'll see you on the flip side. Take care.